Programming Throwdown, episode 59, Deploying Software. Take it away, Jason.
Hey everyone, I have some pretty cool news. So I've done some digging into t-shirts. I found out something kind of interesting. So there's two ways to get t-shirts printed. The first way is ink printing, and that looks okay. Like, I don't really want to bash it too much, but it's not what you expect. Like, when you see a t-shirt, like a professional t-shirt someone's wearing, this is not that. Like, this is just it looks like kind of stained. Then they have screen printing, and that's like the real deal. So I found a place that will do screen printing, but the caveat is, we have to put in our order in advance. So, they just print it all. Like, I guess you have to set up some equipment. They print it all, and then they kind of tear down the equipment. It's not really quite an on-demand thing. So I set up a straw poll. I'm going to post a straw poll in the show notes and also on Facebook, Google+, all of those social media channels. And go on the straw poll and vote your size. If you want to buy two, vote twice. So I've set it up so that you can do that, and put in your votes, and then we will bulk order the t-shirts, and I'll try and figure out some way to get it to everyone. But put in the order now, and then also send Patrick and I an email, so we have your email address. So put in the order, like the vote. That way we kind of have an idea of how many people are interested and things like that. Also email us. And let us know what size you want. That way we have a way of getting back to you. And let's make some awesome t-shirts. I'm really excited. The design looks awesome, and I think this is going to be pretty killer. So that's the intro. Let's do news and links. So my first news item is Keras, and specifically it's Keras.js. So Keras is a neural net library. The idea is you have a neural network, which is a sort of nonlinear composition of functions that's meant to sort of, kind of learn some mapping. So, for example, let's say you have a bunch of weather data. You have the day of the year, like is it February 14th of whatever year, and what the weather is. And you want to build some model that says what tomorrow's weather is going to be. You could run it all through, a neural net. And it will approximate, it will kind of interpolate, based on the averaging and all that, what the weather is going to be like. So neural nets are very, very popular for doing machine learning. Keras is a pretty cool library. The reason why I mention this is they made something called Keras.js, which is pretty cool. The idea is you can take a model that's trained. So you could take, your weather model that you trained with Keras, and you can actually run it in the browser. So someone can actually have your model running in their browser and play with the days and get different weather forecasts and things like that. So I thought, especially for building tools and just for visualization, it's kind of cool.
So I guess to kind of elaborate more or whatever, because I know a lot of people are curious about machine learning, but don't always exactly understand how it is. When you say they run the model, what you're saying is you've trained it previously in some other way, but they can actually take a given set of inputs and get the results without kind of training or changing the underlying model that's already been trained or the weights that have been given.
Yeah, that's exactly right. And the reason why this is kind of really interesting and hard is they actually run it on your GPU. So, these models, obviously training it is very difficult, but even executing the model, if it's really big, imagine if the model is doing some kind of crazy image processing where it's, taking your face and putting a dog face on it or something, like overlaying a dog tongue on your face, like what Snapchat does. Those kind of models are really complicated. And you can download, a model which does that, so you don't have to train it yourself. They've trained it on a bunch of people's faces. But even just running that model in the browser, it just would run way too slow unless it used your graphics card. And so I don't even know how they did this, but somehow I guess there's a JavaScript library for accessing your graphics card. It's probably WebGL, right?
Well, it's open source, so we can look at the source and figure it out.
That's right. So they're probably they probably did some crazy WebGL hacking or something. I have no idea how they did this, but it's fascinating. And they even have some sample models, which is pretty cool. There's a model where you can draw on the screen and it'll tell you what number you drew, like if you drew a 3 or a 4. So yeah, check it out. If nothing else, check it out as like a cool toy to play with. But if you're into doing machine learning, check it out for realsies because it's pretty cool.
I should also say Snapchat is probably not using a neural network model or a machine learning model at all for applying a tongue to a face.
Really?
Yeah.
Well, they have to detect your face, right?
So, maybe, but I mean, you could do things like detect features of the face, like through SIFT or some other kind of features and tracking and putting it on. I mean, do you think they're evaluating, like they may have like a eye detector that is a model, but you think they really have a apply tongue to face thing?
Oh, no. You're totally right. So yeah, they have like the neural net says an eyeball is here, a nose is here. And then from there, they kind of guess. Or maybe they have a neural net that figures out where the corners of your mouth are or something. Yeah.
Right. Or even just more traditional image processing for doing those things. I mean, I don't know what state of the art is or how well it works. I've never used that feature, to be fair.
Yeah. So people used to do a lot with like SIFT and these kind of like, they're called unsupervised methods. The idea is, SIFT is just like, it's a way to just say, look, this part of an image is interesting. And someone has taken so many images over such a long period of time that they have this kind of interesting detector. A lot of people are moving from that to neural nets where they have labeled data and they say, I want a corner of mouth detector. So that's kind of the state of the art. You're right, though. Snapchat could probably get away with just using SIFT. The accuracy would be like a little less, but it'd probably be fine for most things. I mean, most people are looking right at the camera.
Well, also they need to be able to do it, they're probably willing to accept less accuracy for something that runs more quickly on a bunch of devices.
Yeah, that's a good point. Yeah, great point.
But those are the kinds of things you have to think about. There's some trade-off there.
Yeah, I mean, in general, like neural nets they're super old, but they weren't that popular until maybe 5 years ago or something. And so, now like phone companies are starting to catch up and things like that. But there's still a lot of, as Patrick said, a lot of devices where, you could run SIFT pretty easily, but you can't run a neural net.
So the next news article we have is called More Interesting Mazes and it's on, I don't actually know how you would pronounce the name of this website, but it's been around forever. Gama Satura.
I call it Gama Sutra, but yeah, you're probably always right.
It could be. Yeah. So this is, you've probably seen them before if you've hung out anywhere. I don't even know how far back they go, but they run a lot of articles about technology behind making games, game development. They host like postmortems for failed games. And so there was an article I read a few days ago about generating interesting mazes. And this is, at first I thought it was going to be about, the maze that you did when you were, well, maybe you still do them, but where you have an entry point on one side and an exit point on another. Yep. And you're trying to go through the maze. But I guess it's kind of just talking about more generally a maze being a mathematical term where there are rooms and walls and there is only a single path between any two rooms.
So kind of like Doom, like the levels in Doom.
Exactly right. So talking about like levels for a game. Although, I mean, you could have multiple paths. There isn't anything wrong with that. But if you restrict yourself to trying to have a unique path between two different points, and then kind of going about how an algorithm would generate a maze, and there's like a lot of naive ways of doing it. But then if you kind of start adding coloring to the various, you can think of it as like a grid, and to the various nodes on the grid adds different coloring and run the algorithm, you can kind of generate, and it has if nothing else, you can just go through and look at all the pictures. They're kind of cool, where they generate
awesome.
Slanted mazes and, circular mazes, recursive mazes, and just talking about all the different ways to generate. And I, it doesn't kind of call it out, but this is very similar to kind of procedurally generated, or I feel like this is sort of similar, where you're kind of taking a notion or a description of how to do something and then kind of applying that to a whole area.
Yeah, totally.
And so they're producing what looks like really interesting designs and patterns from relatively simple rules.
Yeah, this is awesome. This reminds me of, and I think we talked about this years ago, that cellular automata that made cave mazes.
Oh, yeah.
Yeah, this is so cool. I wonder, I mean, you could make a maze app for kids where, they have to draw from one side to the other, and it could just keep generating mazes. It would never stop.
Yeah.
Cool.
But I mean, I guess this is an interesting thing where you can make many valid mazes, but if you don't kind of teach the computer what is an interesting maze, then the maze could be really boring.
Yeah, right. Or super, super hard, right? If there's only one path or something.
Yeah. And there's like ways of measuring that for mazes, but people talk about the same thing for like Sudoku, that, there's like the ratings on the puzzle, and there's kind of a way to quantify how hard it is. But then there's an argument where people say, oh, humans create better Sudoku puzzles because they kind of craft an experience through the solution versus the computer doesn't. But over time, the computer can be taught to do the same thing. And so it doesn't work anymore. There's a thing that still floats around. I was reading some about it with the recent AlphaGo, where people, for a while, the best way to play chess was you run a bunch of computers, and then a human makes judgment call about which computer's kind of giving the best answer. And this kind of hybrid human and computer approach. And for a while, that was like considered better than either humans or computers. And so a lot of people actually, that became kind of like a notion that a lot of people still think is true, even though now computers far surpass, like if a human gets involved, it'll just make it worse. And so,
yeah, actually, what you're describing is kind of interesting because there's a surge in a new method. There's a ton of research papers that came out this year on this method called generative adversarial networks. And it's exactly what you described, except instead of a human, it's another algorithm. So basically, you have one algorithm or many that generate solutions, let's say. And then you have another algorithm that kind of gives you a thumbs up or thumbs down. And the algorithms that got a thumbs down on their solution, they are disappointed. like they kind of change the way that their function works. And the ones that got a thumbs up, they're like reinforced. Like they want to do that again. And so the idea is they actually used it for generating art. So they built this one algorithm. All it does is it looks at a bunch of fine works of art and a bunch of random images, and it learns to distinguish one from the other. And then they have a bunch of other algorithms that try to generate fine art. And this first one, tells them how good they're doing. And it turned out if you do this enough, you can actually make your own art generator where you kind of seed it with you could seed it with a picture of a robot and a Van Gogh painting, and it'll find some way to integrate those two together that makes the fine art algorithm happy.
Oh, interesting.
Yeah. We'll make that a news next month.
But yeah, so anyways, more interesting mazes. That was a little bit of a side stroll, but
yeah, no, that's totally awesome. Check it out. It has a bunch of really cool pictures of mazes. Very compelling. Makes you want to solve them all. I guess you can't though, right? Because they don't have a beginning.
Well, you could because any two rooms are only connected in one way. If you put a random start and a random finish anywhere,
oh, there you go.
It'll be
then
valid.
Solve it.
I think.
Yeah.
I didn't think all the way through that, but
yeah. All right. My news is something pretty cool. It's called MyPy. It's static typing for Python 3. So you see a lot of languages that have this. With dynamically typed languages, like they do this goofy thing with the annotations where at the top of the function you do like @ int, and it just feels so like ugly and kind of hacky and crafted. This is not that. This is finally statically typed Python that looks nice. So like for example in the function parameters, it works just like hack did to PHP. So in the function parameters, you just put the name of the parameter : the type. And if you don't put a type, it works just like Python. But if you put, : type, then MyPy can do something, do something clever with that. So, if your function is, x:\int and someone passes in John to your function, the MyPy checker, it's not a compiler really because the Python compiler handles that. This just checks it and says, no, you did something that's not legit. This is super, super important because of, code aging and because of many people working on the same code base. I mean, if I have a function that takes 2 ints and a string, and I decide that the middle int, I don't want it anymore, so I just delete it, and people are calling into my function, Python will, depending on how the person calls into the function, Python might actually accept that. Like if I have an args component at the end or something, and the program will behave in a very strange way and no one will know why. So this static checker catches those things. And I can't tell you how many times this has saved me in languages that have this, like TypeScript and Hack and things like that. I mean, I constantly advocate for, strong typed languages. And this kind of brings it to Python, which I think is pretty awesome.
There seems to be the current trend is away from untyped or dynamically typed. I guess not untyped, but dynamically typed languages. The pendulum seems to have swung back to adding types or having types.
Yeah, I mean, now that they have the, what's it called? Like Haskell and Scala, the type inferencing. Now that they have the type inferencing where most of the time you don't need a type, but some of the times you do. Like, for example, if you have a function, the parameters need to be typed because there's no information to be gleaned there, right? But if you have, x equals 1, you don't need a type because it's just right there in front of you. And so, type inferencing has allowed, programming language designers to only, have you put a type when it's really needed. And I think that has made strongly typed languages just, much more, like all the value is still there and the penalty is not so much.
Well, that's if you're very aggressive in using auto in C++. It's sort of the same way. A lot of times auto is a shortcut for a very specific type, and the type cannot change, and it can only be one type. But like the compiler will figure it out instead of you needing to write it out.
Yeah, exactly. So, I don't know. Does your editor do this? If you mouse over a variable, so I haven't done C++ in a long time. If you mouse over a variable that's auto, will it tell you the type?
I use Eclipse and it won't, but it will tell you if you got it wrong.
Like when you compile,
if you have auto, foo equals some constructor, and then you do foo dot, it knows the type of foo, but if you hover over foo, it just gives you the line where you defined it.
Oh, I see. Maybe it's just a UI change. But for Scala, whenever you hover over a variable, Eclipse tells you the type. It's super valuable.
Oh, that's nice.
Yeah.
Well, talking about C++, nice. The 2016 CPPCon just concluded, and I had previously leading up to it, I guess I've never really traveled to a convention like CPPCon or visited or attended. Seems like it would be cool.
Yeah, it sounds awesome.
Just never gone.
We should go. I mean, I feel like we're doing ourselves a disservice.
Right? There you go. We'll have a boondoggle, business trip.
Yeah, that's right.
What's the next one in Hawaii?
Yeah, exactly. I was thinking the same thing.
But there are several topics that caught my eye or I'd come across them in Google searches. And the nice thing is after CPPCon, they do release all the videos just on YouTube. And so it's not really a news article, but a helpful link is if you go to the uploads portion of the CPPCon channel, which will link in the show notes, or you can just type CPPCon, one word, into YouTube. You will see a list of the 2016 talks. I don't know if they're all up yet, but they have a whole bunch up now. It looks like they stopped uploading a couple days ago, so they must be almost done or done.
Yeah, there's hours and hours and hours of talks.
There are some really good ones in here. Like, I don't want to name any because I know I'll mess some up, and also I'll butcher some of all the speakers' names.
Yeah.
But Herb Sutter has some good ones in here about kind of how modern C++ should work and how you should use pointers and memory ownership and transfer. That's really enlightening because a lot of people still develop C++ as they did a long time ago, and C++ is, well, I don't know if you can say it has changed. I mean, it has changed, but you can still do all the old things. But there are kind of newer ways that are mostly just strictly better.
Yep.
And so if you're not writing modern C++, most of the time you're probably missing out. There are probably rare occasions where you shouldn't or can't, you don't have a compiler which supports modern C++. But there's a lot to offer in kind of the modern way of doing it.
Yeah, absolutely. Yeah, I mean, think about how many wasted, like how much wasted code is, for int I equals 0 or for some iterator, and you have to define it and increment it, and, and with auto, I mean, yeah, there's a ton of new stuff. It's really cool.
And so there's a lot of stuff in here, I think, even about proposals for, I guess, what will be 17, C++ 17. And yeah, all the talks I've watched part of have seemed really well put together, and I really liked what they were saying. But I assume there's also stuff in here that's considered controversial or just someone's opinion about the best way to do stuff.
I've seen like a lot of convention drama recently. There was I can't remember. I think it was Ruby on Rails. There was a convention where a guy got kicked out. I guess he was making some rude jokes or something. But like, oh no, it wasn't Ruby on Rails. It was Node.js. There's a Node.js conference, and this guy made a couple of rude jokes. I didn't think they were that rude. They were kind of rude. And like they kicked him out. Like he was supposed to speak again the next day. They kicked him out. And then someone got kicked out of another conference a couple weeks later. So yeah, don't be rude at conferences.
I was also wondering like what it takes to present at such a conference. Like, I mean, I know you apply and you kind of send in what you would like to talk about, but I feel I would feel very, I mean, we do this podcast, but I would still feel very intimidated to get up at a, C++ conference and present something C++ related. Personally,
sure
I just find that like super scary.
Yeah,
but
I think they're all developers. Like, they're all C++. So it's probably a pretty tight-knit community. That would be my guess.
Yeah, if you went to them, you probably wouldn't be. I guess because I've never listened to a conference, the thought of presenting at one seems really intimidating.
Yeah, I mean, the thing about it is the audience of C++ is obviously enormous, but like the developer base, I don't know, how many people do you think, have written more than 1,000 lines of the C++ compiler? Probably not that many.
Oh,
maybe.
I see what you're saying. So you're saying it isn't people who write C++. You're saying it's people who are kind of nerd out on the language itself.
Yeah, exactly.
So it's not C++ users, but when you say C++ developers, you mean people working on Clang and GCC and
like
libraries.
They might be,
libraries.
Hundreds of thousands of C++ developers who watch the talk, but who actually go to the conference. It's probably just a core group of people.
I guess I should have done more research for my news article. I don't know what the intended audience for the conference is.
Yeah, actually, I'm just speculating. I don't know either.
I assumed it was probably a C++ users conference.
Maybe. Yeah, I wonder.
It's okay.
Well, the videos have been up for 6 days and they have 1,000 views. So yeah, I mean, it's probably, it probably is for users, but hardcore ones like you.
What? Oh, wait, that's a compliment. Nope, an insult. Yeah. I'm not sure.
No, it's definitely a compliment.
All right. Well, time for Book of the Show.
Book of the Show. My Book of the Show is a bit of a cop-out. This is a website, Bayesian Methods for Hackers.
We've covered this before.
Yes, it's a website we've covered before.
Yeah.
And this is a book. So the website was so popular.
They printed it out.
I'm sure in no small part because of us.
No.
and maybe because it was on the front page of Hacker News for months and months. But the website was so unbelievably popular and so enamoring that they printed a book. The book is literally the website, in a nice format. But I think it's awesome. I'm going to pick it up. It's a great reference material. There's the thing about, this Bayesian, it's really, a lot of it is about explaining uncertainty. And this is something that I honestly feel like everyone with a CS degree needs to know. Like, let's say you do make, it's a good example. Like, let's say you want to make an AI to play Risk. Well, Risk has a lot of chance, right? I mean, you roll the die, sometimes like you win, but then you could even, forget about making a perfect, like an amazing player, but even just making a basic player, there's risk, but you have to kind of make decisions in a domain where you have this uncertainty, and you have to be able to adapt to the uncertainty and kind of model that. And I definitely, when I got my degree, I had no idea how to do that. And I even, I knew a lot of AI and machine learning, but everything I knew was what's called frequentist, which means you don't model the uncertainty. If you flip a coin once and you get heads, you just say that coin can never be tails because I've never seen it. And so this is the heads coin. And you could get, far with that. But I think, whether you're doing machine learning or not, all of us who write software have to deal with uncertainty. And, for that reason, I love this book because it caters for people with a CS degree and kind of walks you through how to deal with these kind of circumstances. And if you ever played, Civilization or any of these games, and you think like, how does the AI do this? I mean, there's all this chance. Like how does the AI? How can it plan for that? This book is for you. It's a really good read. It's not hard, not too heavy, and check it out.
I read, which is not my book of the show, but I will mention it. Maybe I'll make it a future one. Is The Signal and the Noise, or Signal by Nate Silver. Well, it's what would you call that? A popular book? No, yep. It is popular, but it's written for a general audience. Mm-hmm. And so he does in there discuss exactly what you were talking about, the difference between Bayesian and frequentist views of the world, and has some kind of cogent examples, and talks about how predictions, which is kind of like the main subject of the book, is about like Bayesian thinking, is about making predictions and evaluating if you got your prediction right or wrong.
Yep.
And so how that, in general, we should be moving to that because it kind of better fits the world.
Yep. I mean, it's very hard. Just to let people know why everything isn't Bayesian. The problem is, instead of thinking about things in terms of numbers, you think about things in terms of distributions. Kind of like the Schrodinger's cat. It's like this coin, it isn't heads, it isn't tails. It's, 50-50. And the problem is the world is more entangled than we can understand. And not we as in human beings, but it's very hard to make a machine understand the entangled nature of the world. Like, for example, if you have a feature in your model called day of week, it can't be Monday and Tuesday at the same time, right? Like if it's Monday, it's not Tuesday. But, for the model to learn that, it has to see all the pairs of features. I mean, if you tell it explicitly, then sure, right? But in general, the model has to look at all the interactions of all the variables to figure out which ones are sort of entangled. And that is super, super hard, and it requires an unbelievable amount of data. So for these reasons, it's very hard to get Bayesian stuff to work when it gets, really complicated. And that's why when everything was complicated, in the 60s and the 70s, people couldn't get there, right? But now it's starting to become more popular.
So that maybe I'll talk about in the future. But he has a lot of case studies about kind of failures of prediction. Anyways.
Yeah, we should definitely do that because I've heard good things. I haven't read it yet. I'll read it.
There you
You've
go.
already read it, and we'll
it
talk
could be our
about
book club.
Yeah.
So my actual book of the show, which seems anticlimactic at this point, is 0 to 1 by Peter Thiel, and I hope I'm saying that last name correct.
Yeah, that's right.
Okay, good. And this is his view on startups, on a broad-ranging set of topics, I guess. And it is mostly about the difficulty, exactly what the book describes, of going from nothing to something, which is as opposed to what most companies do, which is once you already have something, trying to improve that something, which is like from 1 to 2, for instance.
Right.
And so going 1 to 2 is a very, very different problem than going 0 to 1, and how that confusing the two is never going to really work for you. You're going to have problems.
That makes sense.
It sounds really obvious when you say it that way. It's also him just kind of talking through some of the stuff behind what he's done, a little bit of a biography, I guess, with his work in PayPal. And then some notes about how when he runs a venture capital firm, how interestingly, if you try to go for the companies you think have the highest probability of success and you build a portfolio out of them, your portfolio will probably not do very well. What you actually want to do to some extent is increase the variance, looking for companies that have a great idea but a very low chance of success. But what you need is for them to go 0 to 1 and return, 100,000 times your investment. And then it'll more than make up for all the other money you invested in the other companies. And,
I see.
And this is probably my opinion on kind of his thinking there. But the way I kind of take that away is when you hear people saying, why in the world would people invest in this company that seems silly? If it's silly because it's a radical idea, then it's probably very much merited, even if it's almost guaranteed to fail. But if you hear about a venture capital firm investing in something that has a very low chance of returning 100,000x on, even if it's successful, it's not going to move the market, then that actually might be a venture capital firm that isn't of the same caliber of what Peter Thiel is advocating is kind of the right way to do that investment.
Oh, that makes sense. This sounds like there's something called novelty search, and it works like this. So the idea is you have kind of some function. You can give it inputs, you can get an output. And the way novelty search works is novelty search, if you give it a certain set of inputs, you win, but you don't really know what those are. So with a regular type of search, you would start with something random, and then you'd start with something a little different, and you'd see kind of did it get better or worse. This is called hill climbing. And as you just keep tweaking things, you get better. And at some point, you get to the point where no matter what you change, it gets worse. That's called a local optimum. And you just say, okay, I'm done. Novelty search is kind of interesting. You feed in a set of inputs, and then you feed in a different set of inputs, and if you get the same answer, that's bad. So if I feed in, the second thing and I got the same answer, I want to stay away from that part of the input space. So if I feed in, if I change, the second variable just a little bit and I get a totally different answer, then I know, aha, the second variable, that's where all the interesting, that's where all the variance is. And so it's kind of like you don't even care about the answer you get. You just care that it's different from the other answers you've seen before. And so it's interesting. Like Peter Thiel is basically advocating novelty search when you're investing, which sounds super dangerous. But I mean, it makes sense, I guess. I mean, if that one thing they find is that valuable, then it makes sense.
He also has thoughts about monopolies, which is interesting, and how monopolies can be good and you really want to invest in them. But, kind of like what are the downfalls of it? But, he talks about a lot of people kind of think they have a monopoly, but they don't. And then you just end up in a market that's a race to the bottom.
I see.
And then how he has some thoughts about, is Google a monopoly? And why or why not? Or a de facto monopoly, anyways, it's interesting. I don't want to, spoil it all or give my interpretation, which is probably not right. So go listen to him tell it. And,
I will totally check that out.
Although I guess now he's gotten into some political stuff. So people might not like this suggestion of mine.
Oh, yeah.
This is not in regards to that. This is just in regards to the book and him talking about startups. That's why I listened to it.
We were racing each other to give that disclaimer. I mean, I don't want to get involved. This has nothing to do with politics at all. This is Peter Thiel talking about his companies.
He has a lot of interesting political views as well. And some of those are in this book, but not his really recent ones, because this book's a little bit old. I don't remember when it was released. And so, this is a portion of the show where we get to plug some stuff. And I actually did listen to this book and all the books I listen to because I have a long commute on Audible. And we do have a affiliate link with Audible. And if you go to that link, you can get a free credit, which is good for basically any book that they have in their library, of which they have many, many, many books. And if you go through our link, then we get a little bit, you can help the show and get a free book. And then you can cancel after you get the book. Or if you don't, then you'll just get a monthly subscription and get a book every month, which is what I have. And actually, my wife started listening. I don't know if we can say that on air. Oh, well, my wife shares my account. And so it lets us do that.
Fine.
And
people won't judge.
I hear everybody talk about HBO all the time. Apparently, there's like only one HBO login in the whole world.
With Hulu, I think it's Hulu. No, sorry, not Hulu. With Spotify, they crack down.
I know. Yeah, like Hulu and Netflix, like there's a limit to how many streams. Anyways, this is off topic. So, now my wife's actually gotten some books. And so she's like, wow, this really actually is good. I enjoy listening to these books while I'm in the car where I would otherwise just listen to the same songs again or whatever. Yeah,
I need to do this. I've been reading books on the bus, and lately I've had to work a lot of overtime. And I've been reading books. I feel like, doing slow but permanent damage to my eyes. like maybe, listening to books, even though I'm on a bus, just closing my eyes or looking out the window and listening to books would probably be much healthier.
I knew someone who listened to books while they were working. I can't do that. Like, it's too distracting.
Yeah.
But while I'm in the car or, whatever, I do it. You can also listen to podcasts like this fine podcast.
That's right. Don't get an Audible subscription if you have to choose between Audible and our podcast. But if you have the luxury of doing both, which you should because we're only on once a month, then check out Audible. You go to audibletrial.com/programming throwdown, all one word. We also have Patreon. So Patreon is a pretty cool service. You can actually download the episodes from Patreon. I know some of our Russian friends can't get the episodes from their source. I'm still looking like a better way to handle that. But at the moment, you can download the MP3s from our website or from Patreon, which has a really high speed connection. If you're a Patreon subscriber, you go to patreon.com/programming throwdown. It's as little as, I think $1 is the minimum, $1 a month. I don't know if you can donate.
Well, it's an episode, right? It's per episode.
But yeah, we keep the episodes once a month. We're not going to we're not going to purposely shill you and put 10 episodes a month or something. I don't think we can even do that.
Episode part 1, episode part 2.
Yeah, right. But yeah, anything you give helps out the show. It goes to things like, designing this t-shirt. So we appreciate, all of your donations.
So being the last episode before the election, I have to make one joke based on what you said about, which you are right. Several people have written in that they can't download from Russia, but they can read all of our politicians' emails. But they can't listen to this podcast.
That's our problem. We didn't have our RSS feed on WikiLeaks.
So we just need Julian Assange to decide that this is controversial, and then everyone can get a chance to listen to it.
Yes, Julian, if you're hearing this,
I'm sure he listens.
Yes, I'm sure he listens. Hack my computer and take all my Programming Throwdown episodes, but please leave my credit cards intact.
Please, no one do that to any of my stuff.
Yeah, joking aside, don't ruin my life, please. I know some people out there are good enough to do that, Uber hackers, and that would make my life hard.
Tool of the show.
Tool of the show. My tool of the show is... How do you say that? Termeter.
Why is
Termeter?
Oh, sorry. I won't interrupt you.
Oh, that's Termeter, which I guess is supposed to be like thermometer or something. I don't know. But the idea, so the way I work is I write a lot of kind of scripty tool kind of things, prototypes, things like that. And I want to work very quickly. And usually the code I write has to be rewritten. Like once, the target keeps moving, we're learning a lot, and then we say, okay, this model works now, rewrite it. So for this reason, I need to work fast. And usually, I'm writing all this code. I have a bunch of prints. It's in Python. I'm printing a bunch of things. And then I kind of have to look through and I see, okay, here's a print saying, iteration 2 and then some data, and then iteration 3 and then some data. And I have to like in my head kind of get the average of all these iterations. And it's just kind of a mess. And sometimes I'm just wrong. Like I just misread it, or I think the average is this just from eyeballing it. And when I go further down, it's really something else. And basically what I need is a way to go from print in Python to a graph. But I need it to be just very, very easy. If it takes more than 10 minutes, then it's not worth it. I can just eyeball it. And Terminator does this. It's amazing. Basically, it uses, Unix pipes to, can stream in data. If you don't know what this is, check out our Unix commands episode. But you could stream in numbers to this Terminator, and it will turn it into a plot right there in your terminal. So you could say like print and then do like ASDF, 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 and then some data. Then, you're going to get all this prints with all these different things. You could do a grep for that ASDF, so on. So now you only have those lines that have those numbers that you want. And you can, cut out those numbers, pipe them to Terminator, and you have a graph. So, it's super, super powerful. I've been using it a lot. It's a lot of fun. I actually wrote my own before someone told me about this. The one I wrote actually does PNGs, so I think I'll keep mine. But this is totally awesome, and it's right there on GitHub.
Now I'm distracted because the movie of the example is this website ASCII Cinema, and so they have a whole bunch of ASCII art
I saw
movies.
That.
Now I'm
Yeah,
distracted
awesome.
by clicking on random ASCII art movies.
So you have nothing else, go to this GitHub page. I really encourage you to get it, but if you don't, check out the ASCII art movie.
And then, follow all of the other ones on that website.
Nice.
So my tool is, unfortunately, this is only, as far as I know, on the iPhone, but they have an equivalent on Android as well, and that is Motion Stills. And so this is a product that was released by Google, and then I don't think it got a lot of traction, but they did integrate the technology that was a part of it into Google Photos. So I think this is how you can get to it in Google Photos. But I will say, if you have an iPhone, it's worth checking out, even though if you also already have Google Photos, which is awesome, and you should get Google Photos. I do recommend Google Photos.
Yeah, me too.
And so what this will do is on your iPhone, if you take a live photo or you take a movie, it will do, essentially image stabilization on the kind of movie that you have, so that the things that are actually moving in the scene kind of pop out to a greater extent. And
is that what it's doing? I was wondering what it was doing.
Right. And so the reason you think, that's not that big of a deal, except that when you have the looping happen and you manage to, before I had kind of live photos turned off and I thought it was just a waste of space. But now I've turned it on almost exclusively because of this. Most of the time it kind of is just like, that's silly or it doesn't work. But occasionally you just manage to capture something where if you're hand holding the phone, it moves just enough that you ruin the effect. But if you run it through the motion stills and you get the live photo where it's just like a person moving or turning to face the camera as you tell them, smile, and then you take the picture, that you get this really cool, much more artistic effect.
Yeah, it's like the whole world is frozen except for your friend.
Well, it looks, more like a cinema or a movie where you have a stabilized camera. But when you're hand holding, you almost always get some vibration in the movie.
Yeah, this is so cool. Yeah, I didn't know, but so if you have Google Photos, you already have this. Is that right?
I believe that for movies, I don't know, I assume for live photos isn't a thing in Android, but if you have a movie, I would assume that Google Photos either at least has has an option to do this, or will do it automatically for your movies.
Cool.
Where YouTube has that as well, where it'll try to motion stabilize the movies.
Very cool. I'll try this out.
You should just go watch the videos search motion stills and watch the videos, because I'm sure my description of it was butchering it.
No, I thought it was solid. It makes sense. Cool. Okay. So now
time
we're
for
going
the
to talk
topic
about
of the show.
The topic, which is distribution. You deploying software. You wouldn't think that this would be hard. It is. It's one of these things that kind of creeps up on you. As a developer, you don't really expect this to be a problem. Like, where do we start? I guess we start with applications. That's kind of the most straightforward. The most obvious question is, I built this thing. It works on my computer. Why don't I just zip it up and email it to someone? I mean, that seems very logical. If you try this, here's what will happen. You and possibly your friends it will run no problem. But for most people, it won't work. And the reason why is, everyone's operating system is in a different state. You might have developer tools that most people don't have installed. You might even have just, a slightly different version of Windows. Like, it's still Windows 10 or XP or whatever you're running. But it's just you have a couple of security patches or a couple of updates that other people don't have. And when it goes to their computer, it just blows up. It ends badly. So basically, don't zip up your program and send it to someone. I mean, you can do that if it's your friend and if it doesn't work, it's okay. But don't zip your program up and email it to your whole school or something. It's just not going to work. Oh yeah, go ahead.
No, I guess surprisingly, it actually is shocking that it does work sometimes. Like, if you think about all the chances for it to go wrong, different processors, different whatever, but it actually has a non-zero chance of working. And that actually is kind of amazing in itself.
That's true.
You can't email, you can't email random, like, stuff from Windows to Linux. Like, that won't ever work because of kind of how the syscalls work between the different operating systems. But if you email it to, your friends and family, there is actually a chance of working. That's actually kind of cool because of how, and that's one of the purposes of the operating system itself, is to make it so that you don't have to be specific to the exact processor you're on or to the exact configuration of everything. But then, like Jason said, there's also a lot of things that can go wrong. And so one of those things that can go wrong are your dependencies, which is the stuff that your program relies on that you may not realize at first, which is, if I install, and it depends on what language you're in, how obvious your dependencies are. But in Python, for instance, if you've just, pip installed something on your computer and you send your Python script to someone else and they try to run it and it won't work, right? That's not sending a binary, I guess, but sending that script and it doesn't work is because you installed something and they didn't.
Yep. That's right.
But even for something like C++, if I use, for instance, DirectX, and I guess this isn't true. It is included now, I think. But if I sent it to Jason and Jason didn't have the same version of DirectX installed as me.
OpenAL or something.
Right. Then I'm depending on some code that isn't shipped with the source code that I compiled. And that would happen if I'm using specifically a shared library, which is some binary that's compiled that isn't an executable, but is on my computer. And on Windows, those would be DLLs, or SOs on Linux.
And even no matter how, even the most professional software development studios still have this issue to deal with. Like, that's why when you install a game on Steam, you get that little box saying, checking for DirectX, installing DirectX. It's because nobody can guarantee that you have it, so everyone just makes you at least check for it.
Right. And so part of distribution is making sure that the shared libraries that are expected on your system are there and that they have a compatible version, because maybe the person has an older one or a newer one that is incompatible with your version. And so sometimes you end up with it must be greater than, and sometimes must be between, and sometimes must be equal to the version of that library.
That's right.
And even if sometimes you don't have shared dependencies, but sometimes or shared libraries, but sometimes there are static libraries where the library is compiled into your binary itself. And that's one way to avoid having to check for it on someone's system, is to just include it in yours when you send it. The problem there is that that's duplicate code, so it makes your binary bigger, because you have to ship with all of the code you use, and instead of everyone being able to share the same code that is the same.
That's right. And also some people won't give you a static library. Like DirectX, I don't believe they have static libraries.
That's a good point.
So, also, it's a little bit of a trap. Sometimes a static library will refer to a shared library, and you won't even know that now you're depending on some shared library that you didn't know about. So yeah, there's a bunch of gotchas. There's certain like low level tricks you can do. Like there's this thing called dependency walker, but you don't want to do any of this. You want an installer that will do this for you. This is kind of like writing your own compiler. You don't want to do this. I mean, unless that's your expertise. So there's a bunch of installers. For Windows, there's something called NSYS, which is a Nullsoft scriptable install system. On OS X, there's Sparkle, which is very popular. And on Linux, there's PPA, Personal Package Archives. They all sort of have kind of different procedures for building your package and deploying it and things like that. One thing I strongly recommend, if you're planning on deploying software to customers or to strangers, or to any large group of people, get VirtualBox and get a version of Windows, a vanilla version of Windows, maybe even 2 different versions of Windows and a version of Linux or what have you, and make sure that you can install your program on that machine, that virtual machine that doesn't have anything else installed. Chances are the first time you try, 9 times out of 10, you'll run your program and it'll pop up an error saying, oops, you don't have, Visual Studio developer files or something like that. And you'll have to add that to your installer. So
it's also worth pointing out for large projects and large programs that doing the installer and distribution and checking compatibility on the platforms is a job for people or peoples unto itself.
Yep.
But for a small team or program, a person is probably doing this along with doing other stuff.
Yeah, and it's very time consuming. When I release MameHub, especially now that MameHub's been around for so many years, I spend more time on the installer than anything else to this day. The past maybe 3 years, every year I've spent more time having maintenance issues on the installer than anything else. Another way, people have obviously gotten sick of building installers and definitely zipping their binary. So they have app stores. You could consider Steam as an app store, right? Windows has an app store. Apple, obviously, with iOS and OS X, they have the app stores. They're called App Store. Android has the Play Store. And basically, along with the store, there's also like developer support. So if you want to make a Windows app for the Windows App Store, they've made it as simple as possible where you hit some button and it does everything it needs to do so that when someone gets that app from the store that it will work on their computer. They provide pretty good guarantees for that.
Yeah, so there's a way to package and describe the needs of your app in a consistent way so that it works for everyone.
Exactly.
Yeah, I guess Steam's a little bit different there because I don't think Steam has the same level of integration with that. Does it?
I actually have no idea how Steam works.
Oh.
I'm assuming that there is Steam. I'm assuming that Steam integrates with Visual Studio somehow. But I don't know. It's a good question. But the continuous, the Steam way that Steam is kind of different is that Steam has a wide variety. It has, DOS programs. It really has to support a much broader base than something like iOS, where everyone's running Xcode, or not everyone, but most people are using some variant of Xcode or Xcode build. So yeah, Steam, actually, it's really interesting. If you work for Valve and you're listening right now, write in, and we're super interested how Steam actually works from the developer side.
So related to this topic, but not quite what we've been talking about, so change of topics lately, is continuous delivery, and we'll talk about continuous deployment. And this is talking about you write the source code as a developer, and then assume you have a system that produces the installer, that describes the dependencies, that packages it up and ships it. How does the process of when that happens occur? And I think this is a topic of interest to a lot of people. The traditional way that it used to be done, I guess almost everywhere, was people would essentially write code, or if you were a small team, you will write code. At some point, people will begin to say, oh, we're ready to kind of build this and ship it. You'll kind of compile it all, package it up, install it on a few computers, VirtualBox, make sure it works. And then when it does, you'll kind of ship it to someone. And then you'll probably freeze that code and then, start kind of making changes against it. And if there's a problem that your customer has or your friends have, you would edit that frozen version and try to like apply bug fixes. And that's kind of a very traditional way of deploying software and the software process. And nowadays you start to hear a lot of talk about continuous delivery or continuous deployment. And we'll talk about the difference in a second. And this is more, once I integrate code into the repository, a series of automated steps begins to occur where it builds my code, it runs my unit tests, it builds the installer, it, maybe runs some integration level tests, checks for problems. And that happens in a system. And you'll hear stuff like Jenkins, which is what will kind of monitor for those events and perform some scripted set of actions. And continuous delivery is about doing that on a very regular basis, like every night or day, or even with every change, doing some set of those tests and integration and making sure that the code is ready to be deployed at any point. Any code you have, it always builds, it always is ready, it passes all the tests, but then it might go through a step of like human QA or evaluation, quality assurance or evaluation or testing before it's kind of promoted to this is a good release or a release candidate. But you still have kind of, you might hear like nightly, or different people have different words for it, but you'll have still installers or versions of the executable for a much more granular, fine-grained thing.
Yeah, and this is one of the things that makes this possible is thrift and protocol buffers and these kind of like very backwards compatible information kind of representation. Like if you have so many different versions, if you're literally putting out a new version every night and you're sort of tweaking the way that data is saved, you need something like thrift or protocol buffer. So someone on version 800 can, migrate to version 802 without having to start from scratch.
That's right. And you begin to see there might be some problems, which is how do you check code into the code base for people to be able to review, but you don't want it kind of running yet, or it's incompatible with some other version. And this is where you start having feature flags come in. So portions of your code are active or not active. And then for continuous deployment is like another step above continuous delivery, where in continuous deployment, you really are, after all of the automated steps complete, you're kind of saying to other people who would use your code, you can now use this. You wouldn't really, I guess, see that in something shipping to consumers. I would think that would be really weird. But for teams where you're producing a library that another team in your company consumes, they may have this where, every night there's a new version of your library produced and their build system just picks that up into theirs. And so you better make sure that your code, and you have the tests and the automation to check that every single one of your changes could have that happen to it, because you don't know when it's going to be created at any time.
Yeah, actually, it made me think of something kind of interesting. Like, I wonder what, for an average software, for average company that develops software, how much of the software you think is used internally? My guess is a lot. I mean, my guess is probably 50%, when you include IT and everything. So more than half of the software you write or your company writes will be consumed only by your company.
Well, I guess it's hard. So if you talk about like a microservices architecture, or even just a regular distributed system, you might have the Amazon front page or home or search page or whatever. there's a whole bunch of services that are behind the application that is really kind of driving most of that. Are those things internal or not? Like, it's hard to say.
Oh, good point. Yeah, I guess internal is a little fuzzy. I guess internal means the binary doesn't leave your servers.
Oh, okay.
That's
but then like every
defining.
website is internal only.
That's right. That's true.
Which we're talking about in a second, but I do want to say that, for like microservice, I said library, but also if you're running a service, you could redeploy that service with every code change or every night, and make sure that you're always on the freshest release.
That's right. Yeah. I mean, one thing maybe people don't know unless they do web development or just this kind of like service-based architecture is it's designed to be very, very modular. And so, for example, if you're making like a funny meme site that has like the funniest memes and people can comment about memes, things like that, you might have a service that all it does is write the meme text onto the image. And it's just standalone. It's maybe in a Docker container or something. And so, that team, you don't want to have this monolithic binary where if anything is wrong with any part of it, nobody can ship their updates. So you have the team that's doing the write the text onto the image. They're doing continuous deployment, and they are, with some degree of certainty, like failing, maybe once a year they blow up the build or something. But it's okay because there's redundancy, and we'll talk about that more later. But yeah, I mean, imagine when you build something for school, you usually build this one huge binary. It's got like your project, and maybe you keep adding onto it throughout the year. But in industry, there's just thousands and thousands of services. Well, depending on the size of your company, but there's many, many services, and they're all kind of communicating to each other and all updating. Almost at least nightly, if not more often.
Well, or at least not in a
amazing.
Coordinated way.
What's that?
There
they're
isn't,
not
yeah. There isn't a coordinated, okay, everybody roll out now.
Exactly. Yeah. So yeah, we could jump into web development. So maybe the first thing I'll talk about is sort of how do you update the website, and then I'll go into, the database. So, the database is, just to recap, database is what holds all of your information. If you're doing this meme website, the database is holding all of those images and your user accounts and all of that stuff, right? And then the website is where all of your logic is, which says, it'll hold some data, but it's meant to be very transient. Someone uploads a new meme, it has to go somewhere. It doesn't go straight to the database. So actually, it does if you listen to last month's talk with Hyperdev. But generally, it goes to some web server. We're not that cool yet. It goes to some web server. That web server kind of accepts it, and says, okay, this user made this meme, and then puts that information in the database. So, so you can hot swap this. So what that means is, if you have a new version, maybe that version is faster. Maybe when you upload the meme, it like turns it into a JPEG or something. No matter how you uploaded it, you could upload a PNG, it turns into a JPEG. So you want to make this change. Well, the database doesn't have to change. It's just storing these images. So what you can do is you might have the most popular meme site ever. So you have thousands of machines, and they're all just super busy making your website work. So you can say, I'm going to change one of these machines to do this JPEG conversion thing. And then you can actually see, if you have the right logging infrastructure, you can see like, okay, I have more JPEGs now than I did yesterday. And this machine is producing a bunch of JPEGs, and it's sane and everything. And then you say, okay, I've done one machine and it looks good. Let's do 10 machines next day. Next day, let's do 100 machines. Okay, let's do all 1,000 machines. And so in this way, you're kind of transitioning people from one version of your site to the other. Another thing you can do, which is what Patrick mentioned, is if you might have a flag which will change all the machines at once, or maybe some of the machines, but it's controlled at runtime. So instead of you saying, I'm going to replace the code in this machine and not the other ones, you say, I'm going to replace the code in all the machines, but only the ones that have this flag set will do something different. the rest of the machines will all continue doing the same thing they were doing before. So you're kind of trusting yourself to use those flags, appropriately and not actually change something on all the machines. And that flag approach is what you have to do if you need to change the database, right? So let's say, I'm storing these memes and my site's getting so popular that I actually have to use a new database that can only hold JPEGs, but it can do an amazing job and it will save my company a whole bunch of money because of the way it handles the JPEG. So you keep the old database around and you start bringing up the new database, and you actually do duplicate writes. So in other words, you say, I'm going to write, the PNG file to the old database, and I'm going to write the JPEG file to the new database. But when I read, I'm going to read from the old database. And then you start monitoring, and what you should hope is that these databases start to look the same over time. That, eventually they should have the same data in them. And when that happens, then you start having machines start reading from the new database. You're like, okay, I'm writing everything twice, and I'm verifying that when I write twice, they're in both databases and it looks solid. Let's have a few machines start reading from the new one. And then you keep monitoring. And then when that looks good, then you kind of switch everyone over. So it's this very gradual process. But, as a person who's using the website, it's completely opaque to you. I mean, it's kind of remarkable that, you could have an Amazon page and then leave it on your browser, refresh 3 days later, and you're probably looking at like the code that's servicing your page is completely different, but they make it look exactly the same, which is pretty awesome.
Well, I think that's all we got for deploying software. That was kind of 3 vaguely related discussions. Yeah,
I mean, and this should kind of tell people, it's hard. It's domain specific. It's not a science. There's a lot of nuance, a lot of craft that's developed over the years, and it's become this sort of craft. There are some people who are like, deployment craftsmen. What did we call them?
I don't like when people say it's an art, but I think that's good. I'm going to use that. It's a craft.
Yeah, like we have production engineers where I work, and they do more than this, but this is one of their expertise.
Yeah, craft. I'm going to use that.
Yeah, like they craft an installer that actually installs correctly. So just to repeat, to sort of recap, the tools of the show were Termitor and Motion Stills. The books of the show were Bayesian Methods for Hackers and 0 to 1 by Peter Thiel. You can check it out on our show notes, get links to all of that.
Which are on Facebook, apparently, and on programmingthrowdown.com.
That's right. We're on Facebook. Someone asked me to start posting them on. That's right. Patrick are you boycotting actively, or are you just
No, I think
passively?
I do have an account. I don't know. I'm not a social person. I'm a terrible human being. So I'm not a social person, so I don't find interest. I think, did I talk about this last episode? I checked out Instagram and it was like, no, I don't read the comments. I just look at the pictures and I'm like, oh, I can get behind this. It's like pictures from people, I think, but like no words.
Right.
I don't like to, like, people say things and it makes me mad or frustrated or, what. Anyways. Yeah. No, I don't do
sense.
Facebook.
Patrick isn't Facebook, but, if we're on Facebook, we're on Twitter, we're on G+, and we're on LinkedIn. Someone asked me to start posting them on LinkedIn. So I said, sure. And some people actually respond on LinkedIn, which is kind of cool. It's a little sad that there isn't one continuous thread of comments that go across all of these networks. It's almost like every time I add a network, it kind of fragments. But I think it actually doesn't fragment, it just grows the amount of communication. But I just wish that
there's a startup to take that from 0 to 1.
Yeah, that's right. Let's get Peter Thiel on this. Hey, follow us on all of them. Then you can see all the discussions going on in parallel.
Maybe a human can copy all of the comments across and keep them all in sync.
Yeah, exactly.
No, don't. That just sounds miserable.
No, definitely don't volunteer yourself for that. That sounds terrible.
Well, thank you all for enduring another episode.
Yeah, thanks a lot. Let me know about the t-shirts. We have a straw poll, vote, and send us an email with your name and what T-shirt you want. And if we get enough orders, we will put in the bulk order. I think we need 25. We'll put in the bulk order, and I'm sure we're going to get 25. But definitely, let us know so that we can get you a shirt.
Well, there's you and me and our moms, so we got 4.
That's right.
We got 4. 21 slots left.
That's right.
Till next time.
See you later.
The intro music is AXO by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.